Data Science. So, but I would like to highlight this as a very important milestone organized by the Department of Data Science, because we have been doing several awareness sessions, several webinar series to spread the awareness about this domain and its applications and its importance, because it is having endless applications. So initially, I would like to thank to Mr. Chaminda Vijay-Singha, our head of the department. Also, I would like to convey my regards to Ms. Netmi Virasinghe, lecturer, and Shabiha Vero, department secretary, because I think they have been working a lot in organizing these things, these webinar sessions from the back end. While appreciating them, and I would like to introduce a special, profound personality today, Dr. Sandeepa Kannangara, straightly joining with us from Australia. So just to brief out a little bit about Dr. Sandeepa, actually, she earned her PhD from University of New South Wales, Australia, specializing into the areas related to machine learning, data mining, etc. And she's a experienced data scientist working attached to Australian Commonwealth Bank. So welcome, and actually we are very glad to have you in this session, Dr. Sandeepa. I hope at Australia it might be almost at evening or might be at night, right?
Night, yeah.
Okay, right. Anyway, despite your work schedules and your other commitments, we really appreciate as a Sri Lankan that you are joining with us to grace this occasion. So we would like to share your expertise with all the attendees here. So the topic actually we are going to discuss today is related to natural language processing, which is, I would say, which is a very important sub-discipline associated with artificial intelligence, machine learning areas, because I personally see that is the way how human beings interact with machines. So there are ample of applications in natural language processing. So rather than I keep on talking, I would like to provide this opportunity to Dr. Sandeepa to share her expertise. So once again, we really appreciate your commitment and providing an opportunity to get in touch with you. So over to you, Dr. Sandeepa.
Thank you, Mr. Kannangara. Thank you for the great introduction. Let me share my screen. Can you all see my slide?
Yes, Dr. Sandeepa, it's clearly visible.
Okay, thank you. So as Mr. Kannangara mentioned, I'm going to talk about mainly natural language processing. This is very broad area. So during this session, I'm mainly focusing on to introduce what is natural language processing, what are the applications currently you can see based on natural language processing, and little bit of technical stuff like what are the approaches, like what are the techniques and tools behind natural language processing. Let me start with, so as I said, this is the main agenda. So firstly, I will cover like, because I believe some of you may already know what is natural language processing, what is machine learning, deep learning. So let's see how these things are interconnected and what is this natural language processing mean in the first section. Then let's talk about few of the applications of NLP. There are more, a lot of things that we can point out as NLP applications, but I selected only few cases that you also may be familiar, maybe using day-to-day life, but without knowing the behind this NLP. And finally, some technical stuff like what are the approaches to do natural language processing. Okay, before talking about natural language processing. Actually, what is natural language? So natural language is that what now I'm talking to, like what you now hear is like natural language. It is the way we or the humans communicate with each other. So if you take text, we are surrounded by text these days. If you say there are emails, SMS, web pages, and so on, this list is endless. And if you think about speech, we may speak to each other sometimes more than we write. So it is even easier to learn speak than to write. Voice and text are how we communicate with each other. So these are the natural languages. And so the natural language processing means they are how we process how a computer or the machines process natural language and produce some output by understanding natural language. So that is called natural language processing in AI. So this field, it's an intersection of computer science, AI, or the artificial intelligence, and linguistic. The goal is to computer to process or understand natural language in order to perform tasks that are useful. However, fully understanding, like when I'm talking, you can understand, but in that way, to machine to understand it fully, completely, and correctly, it's a difficult goal, actually. I'm going to talk about that in next few slides. The natural language processing is not just keyword matching in natural languages. So what we are talking or what we are writing. So the computer needs to understand the structure, meaning of words, sentences, and text, and the conversations. So it's mainly the deep understanding of broad language. As I said, this natural language processing is all around us. Well, let's talk about that later in this presentation. So there are basically two things in this natural language processing. So natural language processing, or the NLP, seeks to convert this unstructured language which is in the form of text or speech into structured data format to enable machine to understand speech and text and formulate relevant contextual responses. So this natural language understanding focuses on machine reading this text through grammar and context and enabling to determine the intended meaning of the sentence. Then natural language generation focuses on text generation, or the construction of text by machine and based on the given data set. There are two-way communication. This is a bit technical. We no need to go in details, but when it comes to natural language understanding and generation, there are several steps that the general natural language processing pipeline need to do. When it comes to text, normally, if it is in computers, so we can just use that, and we can tokenize. Tokenize means we can split those texts into either words, sentences, or phrases in different formats. If the text is in written or the printed format, there are some we can use. People use like character recognition software to convert that into what computer can read. Then follow the process. If the input is in speech, or the origin is speech, then it need to do phonological analysis, which is based on the sound of the words to analyze and feed that into computer. So after receiving these inputs, so firstly, morphological analysis, which is mainly to understand distinct words according to their meaning. So let's, for example, if there's a word called unhappy, then to understand there's a prefix un and there's a word happy in there. So that is the first level of analysis. Then we do lexical analysis, which involves identifying and analyzing the structure of the text, which involves some identifying some grammatical rules and all the things. Then it comes to syntactical analysis. Then it deals with analyzing words of the sentence so that uncover that the next level of grammatical structure. So on, there's a set of steps that need to perform in order to do natural language understanding. I'm not going to talk in detail about each and everything. So when you are learning these things theoretically, you will learn about all these steps. This is just to give you an idea to this process involves several steps, not just the reading the text. So need to understand the structure and all the patterns within the text in order to get something out of that. Okay, I talked about in the previous slide this syntactical analysis. This is an example for syntactical analysis. See, in this case, we have a sentence, eat sushi with chopstick. So we split that into tokens or the words. Then we assign a part of speech tag. Part of speech tag is like, like in English, it means a verb. Sushi is a noun phrase. With is a preposition. Chopstick is a noun phrase. So based on that, we can do syntactical parsing, and this is an example for that. But in case if computer decided to do this in a wrong way, that can completely change the meaning of this sentence. For instance, in this first example, it identified the sentence in the correct way with this syntactic structure, like eat sushi with chopstick. But in the next one, it assumes the whole sushi with chopstick as a noun phrase. It's like we are eating sushi with chopsticks, the different meaning. So you can see the challenge of this this understanding or this syntactical parsing, because these steps need to be done on the machine based on some rules. If something goes wrong like this, so it can completely change the meaning. So that is why we call this natural language processing is a challenging task. There are several other reasons for that. There are this type of ambiguity at many levels. For instance, the word sense, like if there's a word bank, even for human without any other context information, we don't know whether bank refers to finance related to bank or river bank. We don't know if without having any other context information. And part of speech, like whether chair means a noun or verb, it's depend on how we use it within the sentence. So without knowing other things, we don't know whether it's a noun or verb. And also similar to the previous example, this syntactic structure, whether how it passed this syntactic structure. I saw a man with a telescope, or whether I saw a man through a telescope. So there are two meanings of that. And this quantifier, scope, and reference. So then in this example, John dropped a goblet onto the glass table and it broke. So even for us, it's a little difficult to understand what it refers. So this this type of cases are very challenging in NLP. Not only that, with use of social media nowadays, these things like when it comes to syntactic parsing, if we have a proper grammatically correct perfect sentences, most of the cases it can go correctly. But what if we have something from social media which contains a lot of abbreviations and different other types of word which is not from like a proper dictionary words, or not in the correct grammatical order. So it's very challenging. It's not possible in most cases to do correct syntactic parsing or analysis with such language, like in this second example. And also this expressivity, like in English and also in other languages, in Sinhala also, we have like to tell the same thing. We can use different ways. Like in this case, she gave the book to Tom, and she gave Tom the book. So both mean the same thing, but in a different way. So when it comes to understanding these things, it's challenging because it's not possible to teach computer to deal with all these type of various cases. Numerous number of such cases are there, but nowadays people or these scientists or researchers, they develop like a lot of applications or a lot of models which can deal with these type of challenges, and they are still working on those, like continuously improving. So there's a huge improvement in this NLP area. Although there are such challenges, they are like finding answers to these challenges. Okay? Although I talk more about NLP, natural language processing, you may wonder how this fit into this machine learning, AI, deep learning, where this fit, like whether this is a completely separate area, or what is the relationship between NLP and other things. This is how it fit, like NLP is purely a subset of AI, but there's an overlap between machine learning and deep learning. Like to do some of the NLP stuff, we do use machine learning or deep learning. Nowadays, deep learning is the most trending one. So it's the overlap. Nowadays, it's hard to say like we do natural language processing a lot. Most of the cases, it goes with machine learning or deep learning. We are going to see those approaches in later this presentation. Okay, let's move to the different types of applications of NLP. I'm pretty sure like most of these applications you may be now using in your day-to-day life without knowing there's a natural language processing machine learning behind it. Let's see. So this is, if you can observe the first case, it's more like Alexa, Google Home, like you give voice commands and it provides answers. So such applications are purely mostly based on natural language processing and machine learning, mainly deep learning, I can say. The second case is like, you should know this, like there are a lot of targeted advertisements, targeted news articles. If you visit to social media sites or Google, which is mainly targeted to you. So those things are possible with machine learning and natural language processing. And if you know, when you type on Google, so after typing few text or one or two words, so it starts suggesting you the rest of the things. So that is again a natural language, NLP models behind that. And in YouTube, if you see automated captions when we are watching movies on Netflix or somewhere, so those are again NLP models. And recently, not recently, a few years back, Gmail introduced this suggestions when you are typing your emails. So the next few words based on the content. So that is again an NLP model. And of course, this grammar corrections. So if you mistype something, nowadays it's with most of the applications, it's possible to show you the correct word and show there's a mistake in your typing. So that is again an NLP model. So let's talk few cases one by one. Machine translation is primarily mainly use NLP application. It's a process of using machine to convert text from one to another. It's one of the first applications of natural language processing. You may have seen this in Facebook. There are still challenges in this context. If you know, when you type something in Sinhala and when you check the translation, sometimes it was not perfect. If you check that few years back, it was not that perfect, but nowadays we can see it's getting improved day by day. Even if you are using Google Translate over the years, now you will know it has come a long way since this inception. Mainly, it's thanks to this huge advances in this neural network, so the deep learning and the increased availability of large amount of data to train such models. But still, researchers are working on continuously improving those things. Okay, so this is one of the main applications of natural language processing. Next one. You may have experienced this too. These chatbots are everywhere, like in large organizations, rather using someone physically or some person to assist customers. The trend is using these chatbots. It's without these chatbots and virtual assistants. They used to use for automatic question answering, designed to understand natural language and deliver an appropriate response through natural language generation. It do both ways. It can understand the natural language and also it can generate the natural language. Though they're not in the early days, there was like predefined set of questions and answers for this type of thing. But nowadays, it's not like that. There are big like natural language processing models behind these chatbots. Like it can understand what people like what we are typing, and those are learning based on those inputs and improving those models day by day. These are AI powered chatbots, and the best part is they learn from interaction and improve over time. So that is the best part of such application. These intelligent machines are increasingly present at frontline customer support, and because since they can support 24/7 hours, so that is very economically beneficial for the large organizations, rather using some physical assistant to support people. So this is another great application of natural language processing. Sorry. Okay. Another one. This is one type of application of text classification. A famous application of text classification is the sentiment analysis. So normally it says natural language understanding is difficult. It's difficult for machines when it comes to opinion, given that human sometimes people use sarcasm and irony. Even for humans, sometimes when you're reading a text, sometimes it's hard to understand whether this is a positive sentiment or positive opinion or negative opinion. You may also need to give a bit of a thought to correctly understand. So, but people develop different types of models to understand the sentiment or opinion. So there's a huge success in this area. If you know, like there are a lot of applications like this IBM Watson, this different, because although we can't point out a specific application, but a lot of organizations are using these type of applications built inside to assess their customers' opinion. The good example is like, especially during election periods, the countries like US and developed countries, sometimes most cases they use such applications like Twitter or social media sentiment analysis to understand what is the sentiment aligned to each candidate. To predict election results, they use such applications. And also organizations like if they have a customer feedback system, so they can use sentiment analysis to understand what people think about their products. Like for this product, what is the sentiment of people? For that service, what is the opinion of people, like whether they are positive or negative towards that. Kind of, they can do a lot of analysis based on this. So there are numerous number of applications available for sentiment analysis. Again, this is a part of this, mainly based on natural language processing plus machine learning or deep learning. Another example is question answering systems. In some cases it's based on speech, because speech recognition and processing speech is again natural language processing, as I explained in the very beginning. So if you're familiar with this Apple Siri, so it can recognize speech and it can process it, understand it, and can generate text based on that our speech. So that is one great example. Question answering systems, and Google too, like it's based on what you are typing. So if you type a question, it can find the related article. So related answers for those questions. So this is another example of natural language processing. Behind this, there are great NLP models running to provide these answers, or to understand natural language and generate natural language. This is another widely recognized use of natural language processing, is grammar checking. Early days, this was based on mainly just rules. But nowadays, there are a lot of applications which are AI powered, or which use machine learning and deep learning to correct grammars. So nowadays, these are not only focusing on checking grammar. Sometimes those are capable of like providing suitable suggestions to change the sentence structure, like if that type of phrases are not suitable with formal writing, then these type of some applications are capable of like suggesting different format of or different type of phrase to replace. One such example is Grammarly. I think it's available freely for most of you to use. And there are more other applications like Whitesmoke, which use this AI-powered grammar checking. So this is another example of NLP. I talk this autocorrect and autocomplete. So mainly you may have used this with when you are using Google. So when you start typing something, it starts giving the suggestions. This relies on data that the catalog based on the other millions of Google users are searched for when inputting this similar search term. This is possible by using natural language processing that helps understand the subtle between the search terms. And also NLP also help make sense of the data. This autocorrect is another technique that use NLP technology, which is similar to grammar checking, but you can see that in Google. So if you mistype something, so it start giving you like closest possible terms for your misspelled word to change to do your search correctly. So this is again another application of NLP. Text summarization. Maybe you may not familiar with such things in your day-to-day life, but there are applications for text summarization purely using machine learning or the natural language processing models. It summarizes the text. It's the capability of summarizing the text just by extracting most important information. So the main goal here is to reduce the process of going through the large amount of data in news content. So there are two ways mainly, which is extraction based, which extract key phrases and create summary without adding any extra information. And another one is abstraction based summaries, which paraphrases the original content to create new phrases. So these two in outputs are based on the two large pre-trained language models. So we are going to talk about such things in next towards the end of this presentation. With NLP, plus using deep learning and machine learning, such things are possible without human involvement. It's possible to understand the important part from a large text and get the summary out of that text. Another thing, this may be also sometimes new to you, but this is something that largely used by some global organizations, mainly in hiring and recruitment. So when it comes to job advertising or recruiting, normally for large companies, when they publish a job advertisement, they started like receiving hundreds of resumes from different candidates. It's not possible to, it's time consuming even to go through each resume and pick good ones. Therefore, nowadays, these HR departments use some resume screening AI softwares. There are a number of such softwares available, depending on the company. They use different types of such applications to screen resumes, mainly based on the keywords or the key phrases, key skills they are looking for in their job advertisement, and in the resumes they search for such use of such key skills or key phrases of that skills, and based on that they filter out the good resumes matching with their job description to shortlist candidates for the further processing. Likewise, nowadays for candidate assessment, to have initial interviews, sometimes they use these chatbots. Even this became famous during this COVID, because sometimes when people can't visit for face-to-face interviews, a lot of companies try to use this type of chatbots for initial screening. This is again a chatbot, so it can understand what people are typing, and based on that, it can generate language or the output. So such things are using nowadays for hiring and recruitment. These are again NLP applications. Another example is text generation. As I mentioned about this earlier, I mean, Gmail, if you are using, so you know, like it have the capability of suggesting like next phrase or next word based on what you are typing and what you have previously typed in your context. So this text generation is possible with large pre-trained machine learning models, mainly trained with deep learning structures. The next example is a poem purely generated by a NLP model called GPT-2, which was very famous during last 2-3 years. So that those type of models have the capability of generating or the suggesting next sequence of text or next sequence of words. We are going to talk about these models, as I said, in last section of this presentation. So see the place, how long we have came in this NLP timeline. See the smart, how many smart applications are available, despite of having such challenges with NLP or the processing natural language. But there are like this type of excellent, great applications available. And there are a lot to do in the future too. It's continuously improving. If you are interested in this type of area, it's great to start exploring and learning and understanding these things. There are a lot you can do in these areas. Let's move on. I talk about only few applications in NLP. There are a lot. Normally, sometimes people classify this as this early days. There's a spelling checking, keyword search, finding synonyms. Those are also NLP applications, but it says those are easy compared to some other applications. The hard ones are machine translation. Still, those are improving. And the semantic analysis, co-reference, and question answering. So those are very hard applications. There are great improvement, but still improving. Okay, let's move to the last part of this session. Up to now, we talk about what is NLP and what are the applications available around us. But I didn't talk about how to develop such applications, like what are the techniques behind such applications. But I'm not going to talk in detail, like the technical stuff, programming stuff, how to develop, but just to give you an idea what is behind of such applications. In the early days, mainly these NLP applications are based on rule-based approaches. It's the earliest type of AI algorithms. In fact, they define unified computer science before we considered using machine learning to automate everything. So in this type of cases, human create a set of rules, linguistic rules based on some patterns in the text, like if kind of things like if this noun phrase is there after verb, so then this should be the classification kind of set of rules based on the linguistic patterns, and also using ontologies. Like ontologies means like a set of a list with some definitions and some things like to do sentiment analysis. Previously, mostly previous AI models use sentiment lexicon, which contains positive and negative list of positive and negative words, whether then the application consider if these positive words are there in the text, then negative words, then can classify that as a positive text, kind of such rules. These type of applications tend to have like high performance in some use cases. When it comes to generalize, like once we build one application for a specific data set, let's say we build something for let's say political domain, a data from political domain, it's very hard to generalize, apply the same rules for, let's say, healthcare domain. So those difficulties are there, but still these rules, sometimes we use that in the text pre-processing stage in more advanced techniques like in machine learning. When it comes to machine learning in text pre-processing stage, sometimes still we use this type of rules to identify some features. Next advancement in NLP is use of machine learning. If you already learn about machine learning, so generally machine learning pipeline consists of like data pre-processing, then feature engineering, and model training and deployment. When it comes to text or the natural language, so pre-processing involves like tokenization, like split text into words, sentences, or phrases, and different types of parsing, sometimes part of speech tagging, depending on the problem. the next step is like, need to do feature engineering, need to identify features. Now, these machine learning models are based on machine learning algorithms. These algorithms are probabilistic or statistical algorithms. So the inputs to these models, like let's say a naive-based decision trees, support vector machine or something like this, the input should be numeric or the numbers. We can't input text values as features for those algorithms. So when it comes to processing text, our main target of feature engineering is to convert these text values into numeric values. Once we have numeric values, like the frequency of some words, count of punctuation marks, such based on the text data, we generate some numeric values, and then we use that to train machine learning models. There are different types of machine learning models. Some are supervised, which we mainly use for different classification tasks, and some are unsupervised. I think when you are learning about machine learning models in detail in future, so you will learn about these things. I'm just generally talking about the main stuff of machine learning here. So basically, when using machine learning based models for NLP, this is the general process which we can get different types of output based on features and labels, like maybe we can use for sentiment and different types of classification tasks, entity extraction, even translation, and identifying topics or the topic modeling. This is the same pipeline for this type of task. Nowadays, more than machine learning, people use deep learning based NLP. Deep learning is a branch of, or is a subset of machine learning that simulates the way human brain works. It's called deep because it comprises many interconnected layers. The input layers receive data and send it to hidden layers that perform heavy mathematical computations. The good thing here is, compared to machine learning, we no need to do any feature engineering. We can input just the raw text, and then the network will learn the important features. So that is the ease of using this type of models. These are so powerful. So, and the drawback is, to process this type of model, it requires huge computational power. At least you need to have GPUs, most cases. Even these large organizations use TPUs nowadays to process big deep learning models with millions of parameters, and also require large training data set. So those are the disadvantages. Despite of that, these tend to perform really well when it comes to getting the output. More about deep learning, since it's you can say it's a new era of NLP. The advantage of this type of deep learning model is, like, it's feasible to do transfer learning and have pre-trained model for different types of tasks. Like, it's like we are training a big model with a large set of data without a specific domain, like from general text like Wikipedia articles, news articles, such collection of large data set. We train a model, then such models can be used for different types of tasks, like the same model can be used for different types of tasks like question answering, classification, text generation, sequence labeling, and even such models are feasible of, like, if there's a generally pre-trained model, it's possible to use such models, fine-tuning that to your own problem. Like, let's say you have a problem within your organization. Let's say in my bank, if I have a specific problem specific to bank and that text is more specific to the bank, then I can fine-tune such like this type of GPT or BERT model with my own data and can use that for my own classification task within that domain. So even such things are possible. Still last thing, these are the very famous pre-trained language models. Nowadays, people are going crazy with these type of models, like using these type of models for different NLP tasks. These are some of the very famous ones. It's great to know about these things if you are interested in NLP, like this OpenAI GPT-3. It's one of the most controversial pre-trained model by OpenAI. They released that they released the GPT-3. They didn't release the model itself for public use for several months because they had a fear of misusing such models to generate any fake things. So therefore they restricted the use of their model, but I think now it's available. It's an open source one. It's trained on 175 billion parameters, and it can do translation, question answering, and several other tasks just by using that model. So this is a pre-trained model on very large scale, very large set of data. And another great one is Google BERT model. The structure is a little bit different from GPT-3, but I think Google BERT model was released in 2018. With that, anyone in the world can train their own question answering model if they have access to TPUs or the cloud TPUs. And the companies, they release this and they showcase that it can perform different, I think, more than 10 different NLP tasks, including this question answering, text generation. So these are the models behind some of the Google these applications that we talked earlier. And there are a few more like Elmo. It's from it's again a such model, but with different structure, but still can use for different NLP problems, including answering questions, textual generation, and sentiment analysis. Based on BERT model, Facebook also released a model called Robert. It's to predict that hidden text, if there's a missing text in between. So the purpose of this is to predict that, but this type of model also can be used for different types of downstream tasks, like in previous cases. All these models are trained on publicly available very large data sets. So this is the newest trend in NLP. Even I think Facebook recently released a model based on speech text, similar type of model, but not the source is from speech text, and it converts speech into text and use that to train this type of pre-trained model. It's another success in this area. That's the end of this session. if you have any questions, I think it's now time for questions.
Yes, Dr. Sandeep, I think thank you very much. I think it's a very comprehensive session because I think NLP is a vast area which is connected with various aspects related with machine learning and artificial intelligence. And I think you elaborated most of those areas with real life examples. So thank you very much for the comprehensive presentation. So if I directly shift towards the questions from the viewers, so that's a question from one of the participant. Does use of lemmatization and stemming in data pre-processing would do additional improvement to enhance the model performance?
Yeah, so those are, I can say it's depending on the problem. In some problems, yes, it do. But in some cases, it is not, because I experimented those things with different types of cases. Especially, I noticed when we are working with social media data, which is not in the correct English format, the grammatically not correct. In such cases, I found like those are not giving much improvement to the models, but still those are considered as a great pre-processing steps to improve model performance when you are working with more structured language than some things in social media.
Yes, thank you, Dr. Sandeepa. And there's another question. Is Cortana is a deep learning assistant?
Cortana is from, not sure, is it Microsoft? I can't remember.
Yes.
Yeah. I think it's same, yeah.
I think it's also just sort of language processing by taking
the
inputs as you elaborated, yes.
Yeah.
And there's one last question. I think you already elaborated about this aspect during your presentation as well. What are the different areas which NLP is being used? I think you gave a lot of examples as well. Maybe you can quickly summarize on that aspect for the benefit of the participants.
Areas means whenever you want to process natural language, either text or speech, and need to develop a model to do natural language understanding and processing. So then it's the area that you are using NLP. So everywhere when you need to do something with text and speech.
Yes. And there's another question. In terms of data science, a lot of mathematics is involved. Even in NLP, does mathematics play a major role?
Well, mathematics is important to understand how your models are performing, because nowadays, even having mathematical knowledge, you can simply train a machine learning model and you can do predictions, but to clearly understand what is behind that model, it's good to have like a statistical and mathematical knowledge. Yeah, I can say in that way. Like otherwise, I can't say it's a necessary skill to use such models, because I know nowadays there are data scientists coming from different backgrounds. Even without having computer science background, you can be a data scientist if you are expert in some domain, some area, like some people who did like economic area, and they learn how to use machine learning models, and now they are data scientists, even having programming or computer science knowledge, but still it's capable of like developing models if they have that analytical thinking, so it's capable. So then I must say mathematics is not mandatory, but it's good to have things to understand what you are doing.
Yes. Hence, we are running out of time. I will just take only one question. This will be the final question. So why RNN-based architecture models are mostly popular in NLP?
Mainly because of high performance.
Yeah, maybe I
Because
think connected with
yeah,
deep learning as well.
yeah. Because with general machine learning models, there are limitations of transfer learning or generalize such models. Once you train, let's say, a support vector machine model for a Twitter data set for one particular problem. Let's say I train a model for Australian election data or SVM model, but I can't apply, it's very difficult to apply the same model for Sri Lankan election tweets or US elections tweets, because that data content and all the things are different. The features can be different. But when it comes to deep learning models, those are generalizable, and also it's feasible to apply transfer learning with such models.
Yes, I think, thank you very much, Dr. Sandeepa. So I would like to thank you again. And Dr. Sandeepa is an experienced data scientist who is currently attached to Australian Commonwealth Bank, and she is a PhD holder from University of New South Wales in relation to data mining and related disciplines. So I think despite your busy work schedules, I think even at night, I think it's at night at Australia now. So we really appreciate your commitment to share your expertise with us. I know that there might be plenty of areas for us to explore, but time has become a restriction because we have organized this session for 1 hour. So I would like to thank you again, and we are really happy and we are really thankful to have you in this session. I think as a Sri Lankan, though you are currently not in Sri Lanka, I think we really appreciate your commitment towards sharing your knowledge. With that note, I think, yes, Dr. Sandeepa, you want to add something?
Oh no, I want to thank you all for having me, and also it's a great opportunity, or it's my pleasure to contribute to this session. Although we can't cover all the things related to NLP, I try to cover like more general stuff. I encourage you, like you all, to go through about these latest trends and search on those and learn. So it will be great to learn about those things and up to date with the latest technologies.
Yes, thank you very much, Dr. Sandeepa. And with that note, I'm taking permission from all the participants to conclude the session. So I would like to once again thank on behalf of the Department of Data Science of NSBM Green University. We really appreciate your enthusiasm, and we really appreciate that you utilized your time to engage with this session. And we will do the needful to share the recording of this session with the interested parties for more concerned knowledge sharing. Thank you very much to all of you, and stay safe. Thank you very much.
Thank you.